Now we move to 3.2, VLAN in a multi-switch environment. A trunk is a point-to-point link between two network devices. Please remember this sentence is crucial. Later, when we learn how to configure a VLAN and then assign interfaces to the VLAN, configure the interfaces so they can communicate devices. These devices can be computers or switch, such as a switch to computer communication and also a switch to switch communication. Here is important information. So again, a trunk is a point-to-point link between two network devices. Computer is not a network device, and a switch is. Therefore, if you want to configure switch-to-switch communication, the linkage or the type of the linkage should be trunk port or trunk access. Please remember that. We are going to use this very soon. So Cisco trunk functions have following things. Allow more than one VLAN, extend the VLAN across the entire network. By default, supports all VLANs, and also supports 802.1q trunking. So here we have the highlighted links. Switch 1 with switch 2, there is a cable connecting the ports fast Ethernet 01 from switch 1 and also fast Ethernet 011 from switch 2. This cable connecting the two switches. Therefore, the two fast Ethernet ports must be configured as trunk ports. Same as switch 1, switch 3 connections. The two fast Ethernet ports FO3 and FO11 from switch 1, switch 3 respectively, these need to be configured as trunk ports. The networks without VLANs. Without VLANs, all devices connected to the switches will receive all unicast, multicast, and broadcast traffic. With VLANs, unicast, multicast, and broadcast traffic is confined to a VLAN. Without a layer 3 device to connect VLAN 3, devices in different VLANs cannot communicate. VLAN identification with a tag. Tag is a key feature for VLAN. With the tag, we know what packets belong to which VLAN, where tag just an indicator shows the VLAN number. For example, if the packets belong to VLAN 3, the tag will be 3. The IEEE 802.1q header is 4 bytes. When the tag is created in the FCS, must be recalculated. When sent to the end devices, this tag must be removed and the FCS recalculate back to its original number. So here has more information about the 802.1q VLAN tag field. 2 bytes field with hexadecimal number, 0x8100. This is referred to as Tag Protocol ID or TPID. User priority, 3-bit value that supports. Canonical format identifier, CVI, is 1-bit value that can support token ring frames on Ethernet. And the VLAN ID, VID, is a 12-bit VLAN identifier that can support up to 4096 VLANs. For native VLANs and the 802.1q tagging, 802.1q trunk basics, tagging is typically done on all VLANs. The use of native VLAN was designed for legacy use, like the hub in the example. Unless changed, VLAN 1 is the native VLAN. Both ends of the trunk link must be configured with the same native VLAN. Each trunk is configured separately, so it is possible to have a different native VLANs on separate trunks. Voice VLAN tagging. The voice over IP phone is a 3-port switch. The switch will use CDP to inform the phone of the voice VLAN. The phone will tag its own traffic, the voice, and it can set cost of service. COS. COS is a quality of service for layer 2. The phone may or may not tag frames from the PC. So here shows the simple example, the command for showing interfaces, fast Ethernet port 018 switch port. So we use the show interfaces FAO/18 switch port. And as you can see, it gives us the key information about this particular port. The name is Fast Ethernet 018, and its switch port enabled. Administrative mode is static access. Operational mode is also static access. And then the administrative trunking is encapsulation negotiate. Operational trunking, encapsulation native, and so on. And the access mode VLAN 20, it belongs to VLAN 20. Trunking native mode VLAN 1 by default. Administrative native VLAN tagging enabled. Voice VLAN 150 voice.